All right, so here we go. We have a real world situation. This is on our books, page 142. Okay. What do they give us? They gave me a graph that shows an object being launched in the air, and it's doing height versus time. Okay. So is height my X or my Y? Height is my Y. Good. So that means time is my X. Good. From what height is the object launched from? 3 meters. Where did he look at to get 3 meters? Which height? There's lots of heights. Where it starts. Good. The starting height. Okay. We looked at where my graph started. It started off at 3 meters. So that's where my graph is starting. Make sure we do not leave our numbers naked. Don't just say 3, say 3 meters, because we have seconds and meters happening on this graph. So make sure you say 3 meters. All right, once this object is launched into the air, okay, how long does it take to reach its maximum height?
6.5 seconds.
Okay, I'm hearing 2 different numbers. What part of my graph do I want to look for? The beginning, middle, or end?
The middle.
We're looking at the middle, right? We're trying to find its maximum point, its maximum height, right? How long it took to get there is 2.5 seconds. You did. 2.5 seconds. Good. All right. And what is the maximum height? So we're looking at the same point. What is that maximum height? 5 what? 5 meters. Good. All right. So we looked at the beginning of my graph, right? We looked at the middle of my graph, at the vertex. Once the object is launched, how long does it take for it to hit the ground? 6.5 seconds. Where do they look for to get that? On the X, on the end. Good. So 3 meters is where he started. It reached the maximum height of 5 meters at 2.5 seconds. And we also know that it hit the ground, which is my x-axis, right, where my height is 0, at 6.5 seconds. Good. Once the object is launched, when does it return to the height of 3 meters? Oh, so we're looking when it hits 3 meters again, right? So about right here. And that's at 5 seconds. Good. So if we throw something up in the air, it has to come back down. So it's going to hit that height twice, on its way up and on its way down. Let me see your ears, please. Okay. Just singing the song in your head. All right, so how do we feel about looking at a graph and picking different pieces from the graph? Like asking for the maximum height, asking how long it took to hit the ground. Do you feel okay about it? Yeah? Okay. So this next piece, I would fold the corner because you're going to use this chart for the rest of today and definitely on your homework. So I would bend down this corner so you know to come back to this. This is a chart that tells you where to find what piece of the graph. Okay? It tells you where to find it. Put it away. It's going to show you where to find it on a graph and where to find it in the equation. Okay? So, where did the object start? In my graph, we looked at the y-intercept, right? Where the graph started. So on the one we just did, it was the 3, right? It's where it started. If I just have an equation, it's the piece on the end. So if I don't have a picture to look at, I just have an equation that looks like this, okay? The piece that gives me the initial height is the number that's by itself, okay? So I would circle that. I would circle the C in the white spot. That is what's important. So on the graph, we look at where it's actually starting on the Y. In my equation, it's the plus C on the end, tells you where your object is starting. Right? The next question they asked us was how long it took to reach the maximum height. So in our graph, here's our maximum point. How long it took was the X value of that point. Okay? So on my graph, you look for the X. If we do not have an X, we use opposite B over 2A. Okay? Again, we're coming from our equation, AX squared plus BX plus C. We would do opposite B divided by 2A. All right. An example from our warm-up today. So if I gave you x squared minus 2x minus 4, I told you that represented something, and I wanted to know how long it's going to take to reach the maximum height. You would do opposite B. So B right now is -2. So you would do opposite B, which is +2, over 2A, which is 1, which gives me 2 over 2, which is 1. So whatever function that's representing, it's going to reach the maximum height at 1 second. Okay? So the when is the X. Okay? How long does it take? That's time. Time equals your X coordinate. Okay? So if you know when it's going to happen, you can also find out what the maximum height actually is. Looking at your graph, it's going to match the Y coordinate. Okay? In an equation, okay, you're going to plug in X to find your Y. So you have to know the when first. So you have to do the opposite B over 2A to get your X value. And then you can plug that value into your equation. Okay? Again, I'm going to use our warm-up again. We had x squared minus 2x minus 4. Previous slide, by doing opposite B over 2A. We found out that the when was 1 second. To find out how high it is, we would plug that back in. This becomes 1 minus 2 minus 4. So this one would have a maximum of -5 feet. I know that doesn't make sense, but I'm just showing you how it works. Okay? So when is it reaching its height? Opposite B over 2A in my equation. What's the actual height? You got to plug it back into the equation because this equals your Y. But this is going to equal your height. Okay? So we can find out all pieces through graphs and equations. Next piece. Okay? How long does it take to hit the ground? Well, if we hit the ground, that means my height is 0. So that means we're looking at the x-axis. So when it hits the ground is when my height is 0. So we're looking for my x-intercepts. This is when we might have to bring back our strategies of factoring, complete the squares, square roots, or quadratic formula. If we look at the graph, it's physically where it touches the x-axis, right? I think we got, what, one more? So when it reached the height of 3 meters again, you can plug in for one variable to solve the other, okay? Or we could look at the graph again. So here it started off at 3 and went up and went down. We just went across and saw where it hit 3 again, okay? What this is saying is if they give you a time and they want the height, plug it in for x. If they gave you a height and want the time, you plug that thing they gave you into a y. Okay? All right, let's do one. Here we go. Ferdinand is playing golf. He hits a shot off the tee box that has a height modeled by the function h of t equals negative 16t squared plus 80t, where h of t is the height of the ball in feet, and t is the time in seconds it has been in the air. The graph that models the golf ball's height over time is shown below. All right, so they gave me a graph and an equation, right? So you and your table people talk about A and B. When does the ball reach its maximum, and what is the maximum height? Talk to your people. Go. All right, Kevin, I'm coming to you. All right, Kevin's going to tell us, when did the ball reach its maximum height? All right, he said 2.5 seconds. Do you agree? Good. Do you agree that he looked at that point where the ball was going to reach its maximum height? And that the x value was about 2.5 seconds. Braylon, what did y'all say the height was? 100 feet. Good. So looking at the exact same point, but looking at the y gives me my height. All right. Since this table moved on, Rory, what is the height of the ball at 3 seconds?
97.
That's for Rory.
Okay, I'm sorry.
Hold on. Rory, what's the height of the ball at 3 seconds?
It's like, I probably got it wrong. But,
What'd you say?
I said 90 point. I put 65.
Okay, so we're looking at the point where we're 3, right? It's really close to my vertex, isn't it? It's real close. That height, it looks like it's in between 90 and 100. So you were closer with your 90 point something. I would call that about 95. That's what I would call that.
You say 96.
Yes, you want to.
95 feet. How could I know exactly without guessing? Bless you. How could I know exactly without guessing? We could actually plug it into the equation. Didn't you give me an equation?
Oh, yeah.
Yeah. Okay. With this particular problem, we have 2 ways to get my answers. Okay. It's only, stop talking, please. Stop talking. It wants to know the height after 3 seconds. So I can replace all my t's with a 3. Plus 80 times 3. This gives me negative 16 times 9. Sierra, what's negative 16 times 9? Negative 144. And what is that plus 240? 96. Ooh. So DJ, you said 96, didn't you? Did you guess or did you plug it in? You guessed? Okay. So, looking at the graph, we can guess about 95. Plugging it into the equation, we know it's exactly 96 feet at 3 seconds. Okay? When is the ball going to be at that same height again, Vontae?
2 seconds.
So we're looking. So I want to know, when is it this height again? Right, so what's right here, though? It's right at the 2. Yep, this one's right at the 2. So it's going to be, it's okay. It's going to be that same height again at about 2 seconds. The next one says number 2, but we're still looking at the same graph. Okay? So the next one wants to know, when is the ball 65 feet in the air? Talk to your people. Talk to your people. Not here today.
was so dead serious. Y'all need to chill out.
All right, Shauna. When is the ball 65 feet in the air? All right, she says 1 second. She's not wrong, but she's also not completely right. And 4. Good. It's 1 and 4. On its way up, when the golf ball got hit, 1 second after it got hit, going up in the air, it hit 65 feet. But also on its way back down, it hit 65 feet again at 4 seconds. So it's going to be at that height at 1 and again at 4 seconds. If I didn't have the graph, we could make my equation equal to 65, and we could factor it. Okay? Not impossible. I wouldn't call it easy either, because those are not lovely numbers, but it is possible we could do it that way if we didn't have a graph to work with. Okay? But we do, so let's use it. How long does it take for the ball to hit the ground? I'm going to go to Joe. 5 seconds. Good. What part of the graph did he look at, Carly? The X-intercept. Good. The end of my graph. So when my parabola hit my x-axis, you were doing so good. Get back. Get back. Come back to me. All right. How long does it take until the ball hits the ground again? It's going to be 5 seconds until it hits the ground again. Okay. So how do we feel with answering questions from a graph?
Pretty good.
Feel good? Okay. We're going to answer the same questions, but now we're only going to have an equation to work with. Okay? We're going to do the same questions, but only have an equation now. So we're going to beat the test. All right?
You just missed it.
Wait, do it again.
Beat the test.
Yay. That'll be my race. That'll be my race.
All right. Here we go. Beat the test time. A neighborhood through a fireworks celebration. What are we doing right now? Yes, what are you doing? We don't need it. You hopefully you turned it in. They got turned in last week. Okay, we'll do it after this. After this. A neighborhood through guys. A neighborhood through a fireworks celebration for the 4th of July. A bottle rocket was launched upward from the ground with an initial velocity of 160 feet per second. The formula for the vertical motion of an object is 0.5 at squared plus vt plus s, where the gravitational constant A is negative 32 feet per square second, v is the initial velocity, and s is the initial height. And h of t is the height in feet modeled by the function of time t. Lots of information, okay? It wants me to write down the function of the height after seconds. Okay, all that, let's write down what we know. We know the equation. They gave me this equation, right? What pieces of that equation did they tell me? Read through it. What did they tell me? They gave me what? They gave me the velocity. Yep. They gave me initial velocity. They gave me my A, right? They gave me my initial height. So they have given me pieces for my A, V, and S throughout the descriptions. They told me my gravitational constant is negative 32. They told me my initial velocity is 160. How do I know my initial height is 0? It's on the ground. Yeah, so if we're on the ground, it has to be 0. Okay? We know these pieces. So since I know A equals negative 32, I know V equals 160, and I know S equals 0, what can I do with that? Plug them in. Yeah, let's plug them into my function. So what letters are left after I plug in A, V, and S? T is going to stay there, and my H on the outside is going to stay there. So we have 0.5 times A, which is negative 32, T squared, plus VT, V is now 160, and then plus 0. We also knew t was going to stay in my equation because of this right here. This tells me what variable is in my equation. So I know t had to stay. The height after time. All right, let's simplify. What is 0.5 times negative 32? What is it? What is 0.5 times negative 32? What if I ask you what's half of negative 32? Negative 16. There you go. Plus 160t and plus 0 means I don't have to have anything on the end anymore. All right. So part A, we have plugged in what they gave us. There you go. Plugged in what they gave us to get my simplified function. It's the numbers that we plugged in. All right, part B wants to know what is the maximum height. What is the maximum height? Okay. So go back to your chart on 142. What do we have to look for to get the maximum height of a graph? Look at the chart on page 142. Top of the parabola. I don't have one of those.
Oh no, you gotta look for
So, but I don't have that. I don't have a graph. So what did it tell me to do in my equation? We got to substitute my x in. Do I know what x equals? No, we don't know what x is. Can we find it?
Yes.
Yes, we can. Look right above it in the chart. How am I going to get the x? What does it say? What's the formula? Go back to your chart on 142. It's the second one. What equation?
X equals negative b over 2a.
We have to use opposite b over 2a first. We have to find the when before we find the how tall it was. Okay? So to find the when, we have to do opposite b over 2a. Okay? So we have to find the x first before we can find the y. I know it looks like this, I just don't know numbers. Okay? So we're doing opposite b over 2a. What is my b value? From part A, what was my b value? What piece just had a t next to it? 160, okay? So opposite 160 over 2 times a. What was my a? The very first number. Negative 16, right? So we have to do opposite b over 2a, which means we have to do opposite 160 divided 2 times negative 16, which gives us negative 160 over negative 32, which gives me 5. Okay. So that just gave me the when. We know it reaches my maximum height after 5 seconds. So I know it happens at 5 seconds, but do I know what the height is yet? We don't know the height yet. So we're halfway there. So what are we going to do to find out what the actual height is? Someone told me earlier, what do I do with my x value? I think y'all said it. Substitute it back in. Yes, plug it back in. So 5 is now my h or it's my t?
It's your t.
5 is my t. So let's plug it back into my equation, replacing all of the t's with a 5. So my height after 5 seconds will equal negative 16 times 5 seconds squared plus 160 times 5. Okay, I'm going to square that 5. So I have negative 16 times 25 plus 800. That's 160 times 5. Then negative 16 times 25. And then add those together. We get that the height is going to be at 400 feet. So I have now found our y value, which is 400. So even though it did not ask me when it was happening, you had to know when it was happening in order to find out what the height was going to be. Okay, so they say, what's the maximum height? You got to know seconds first. So you got to do opposite b over 2a first and then plug it back in. Okay, this is if we don't have a graph to work with. Okay. Questions for me on this one? All right, you're going to get a worksheet. Listen, please. The front of your worksheet is they're going to give you a graph. We'll even talk about it together. The back of your worksheet is going to be almost identical to Beat the Test. You have an equation, you don't have a graph on the back. Okay? So you need to use Beat the Test to help you with the back of your worksheet. Okay? So, if you don't take your books home, you can take a picture of what's on the screen right now, because that's what you're going to need to use for the back of your worksheets that I'm about to give you.